Electric eels. Electric eels. Focus question. What is an electric eel? Legendary shocker. In 1800, German naturalist Alexander Humboldt went searching for electric eels in what is now Venezuela. He knew electric eels and their shocking abilities could help him if only he could catch them alive. Live eels could help him solve some mysteries of the little understood force of electricity. He knew it was too dangerous to touch the eels with his bare hands. Their shocks could cause violent pain throughout a person's body. He asked local fishermen if they could help. Humboldt watched as the fishermen guided about 30 horses into a murky, shallow pond. He described how the thick snake-like eels rose up out of the water. The eels delivered hundreds of shocks to the horses before the fishermen could catch 5 of them. Humboldt studied the eels and learned much from them. Shocking fish story. Humboldt didn't have modern materials or equipment that would have made catching electric eels safer. His account of fishing for eels with the horses became legendary among scientists. Only recently did a scientist confirm the electric eels to rise up out of the water to protect themselves, as Humboldt observed. Before that, some scientists throughout Humboldt's story might be exaggerated like any fish story. It's a fish. Electric eels are actually long, cylindrical shape. Gray-brown fish that are often yellow or orange below their heads and on their throats. They are more closely related to catfish than to other eels, but their body shape makes them look more like eels. They are classified in the scientific order commonly called knife fish, which all have some ability to use electricity. Electric eel can grow as long as 2.1 to 2.75 meters, 79 feet, and weigh as much as 20 to 22 kilograms, 44 to 48.5 IB. That means they can be about as big around as an average adult human's thigh. Male and female electric eels are much the same in color and size, so it can be difficult for scientists to tell them apart. Unlike most other fish, electric eels breathe air through their mouths. They have gills like other fish, but their gills mostly help them breathe out. Electric eels open their mouths at the water surface and oxygen from the air goes into their body through special organs in their mouths. The waste air they breathe out goes through their mouths and gills. Electric eels need to breathe air every few minutes and can drown if they get trapped underwater. Like most other fish, electric eels have fins. They have small fins on either side of their heads and one long fin along their bellies. Electric eels' belly fins run the length of their bodies. They also have backbones that run the length of their bodies and help them move. Electric eels wave their belly fins in a kind of rippling S shape to swim through the water. They mostly move slowly except when they attack. Shocking fact. Electric eels can rejuvenate the tail parts of their bodies if they are cut off, similar to some lizards and worms. It's electric. An electric eel's ability to use electricity sets it apart from other fish. It is planet Earth's most electric fish. Scientists know that electric eels can protect themselves, navigate, hunt and stun, or kill the prey using their bioelectricity. Bioelectricity is the action of electric currents in the body. Scientists have identified their knifefish and some skates, rays, and catfish that use weak electrical abilities to navigate, communicate, or protect themselves, but none have the powerful attack shock of an electric eel. Shocking medical history. Don't try these at home. Ancient Greeks and Romans held live electric rays to people's foreheads to cure headaches. A ray's shock can cause numbness in humans, so it might have worked. 3 electric organs make up most of an electric eel's insides and give it its powerful shocking abilities. The electric organs start just behind the eel's head, going down its back and on both sides through its tail. An electric eel's body is 2/3 electric organs. The organs are designed to send out shocks from the eel's body which can be compared to a battery with a positive and negative end. The positive end is at the eel's head and the negative end is at its tail. Shocking fact. If an electric eel curls its body around its prey, connecting its head and tail, it can increase its shocking power. In electric eels, electric organs can shock prey with up to 650 volts of electricity, which is enough to kill small animals and stun large ones. Anything in the water within 8.5 meters, 25 feet of the eel can feel the shock. For comparison, an electric eel produces a shock with 5 times the volts of a typical US wild rocket, which can be dangerous to humans. Electric eels are immune to their own shocks, but scientists aren't sure why. It might have something to do with their size compared to the size of their prey, how quickly the shock moves away from their bodies, or internal structures scientists don't understand fully. Scientists do not know that electrocytes and are the special cells in an eel's electric organs that help it shock prey, and that an eel's electrocytes line up in long rows. When an eel uses its bioelectricity, each of the electrocytes delivers a tiny shock at nearly the same time. The stacking of electrocytes and the nearly simultaneous athanales shocked by each one combine and amplify those tiny shocks into one large stunning zap. Stunning attack. Before the attack zap happens, electric eels have to find their prey. These fish live in murky water and they have poor eyesight. They are also nocturnal or most active at night. Electric eels don't use their eyes to hunt, relying on bioelectricity instead. They have a similar ability to bats and owls that find prey based on how sound bounces off objects. Electric eels send out about 50 low-volt pulses, or repeating beats of electricity every second. Plants, animals, and nearby objects interrupted the pulses, showing the electric eels what's around them. Once an electric eel thinks prey is nearby, it quickly sends out a group of 2 or 3 high-volt pulses. The shocks made an animal clench and twitch its muscles involuntarily, which means it can't stop moving. The muscle movement reveals the prey's attack location. When the electric eel sends a high-volt shock, which stops the prey's twitching and sometimes kills it. The electric eels move quickly and shocks the prey through its mouth directly into its stomach. The prey doesn't have time to recover and swim away. Adult electric eels mostly eat small fish, crustaceans, and amphibians. Young eels mostly eat worms, insect larvae, and small fish. Don't swim there. Electric eels are top predators and are common in their environments, which are usually muddy or sandy, slow-moving rivers. Scientists have found them in the Amazon and Orinoco rivers and their tributaries in North and South America. Because electric eels prefer slow-moving or calm fresh water, they can also be found in swamps, creeks, and ponds, or along at the edges of lakes and tropical plains or forests. Because they breathe air, electric eels can survive in water with little oxygen and even out of water for hours as long as their skin stays wet. Electric eels mostly mate in small ponds. Male eels build nests by creating bubbles with their saliva. The female eels lay hundreds of eggs in the bubbles. Male eels guard the nests and hatch the baby eels until they're about 10 centimeters, 3.9 inches long, when the baby eels have to start defending themselves with their shocking abilities, which aren't as powerful as adults. Young electric eels are vulnerable to animals such as crocodiles that might risk preying on them before they grow larger. Future energy source. Scientists understand more about electric eels now than Humboldt did, but researchers are not yet done learning. Scientists at Yale University are looking at electrocytes as a model for cells to replace batteries in medical devices, such as pacemakers, which keep a heart beating. Pacemaker batteries contain chemicals that could percent the patent of the device breaks. Researchers want a battery that won't harm the insides of a human body and won't run out of power. What Humboldt wrote more than 200 years ago could still apply today. We are, doubtless, very far from having discovered all the secrets of the electrical action of fishes. What will electric eels help scientists understand next?